welcome to Science with me. My name is Dr. Erica. I am so excited that you're joining us today. We are in our week of Nobel Prize winning science. It's an awesome unit, 5 different projects, and with each project you get a little slice of the Nobel Prize. You do them all, you'll have your own Nobel Prize at home. It's going to be so much fun. If this is your first time joining us, please make sure that you subscribe to our YouTube channel, get our notifications. You can check us out on Facebook, and of course you can always support us on patreon.com/rosieresearch. It's as little as $1 a week of programming, $4 a month. That's like your coffee. Super easy and some great science for your kids to come home to and learn. Also, it gets you into our Zoom room if you want to hang out during the week and chat about science as we work on these projects together. So today's project, we are going to learn about the 2020 Nobel Prize for Physics of Black Holes. Now this prize was sort of split in two, and even one of those splits was kind of split in two again. Part of the prize, half of the prize, was awarded for figuring out the math to prove that black holes can actually exist. Now, we've been talking about black holes for a long time. It's something that came out of Albert Einstein's theory of general relativity, where he talked about gravity and how gravity, it holds me in the chair right now. It holds the Earth in orbit around the sun. It holds our solar system in orbit around the Milky Way. It holds everything. It helps stars be born. Everything really comes down to gravity, and having a supermassive thing though in your math is usually kind of hard because it's kind of like adding an infinity. Like, how do you divide by 0? It's really tricky. Well, somebody sort of figured out how to manage all of the math with black holes, and that won them the Nobel Prize for this year, 2020, for the Black Hole Nobel Prize. But then also, there were 2 separate groups, so they kind of won the other half of the prize, but they did this independently. They were checking out the Milky Way, and they were looking at, what's going on in the Milky Way today? And they kept noticing some stars swirling around, which was a little odd, because normally you see things sort of orbiting in the Milky Way, but you don't see like things swirling and whatnot. And they took a closer look, and it turns out the galaxy we live in, the beautiful Milky Way, it has a black hole. In fact, the black hole is super massive. It's got about 4 million suns crunched into the space of our solar system. That's a lot. Our sun is most of our solar system in general right now. So to create 4 million suns and crunch them down to pretty much what we're living in, that is a big, supermassive black hole that they found. And so because they found that, they also won the Nobel Prize. So they kind of split it those 2 ways. Now today's project, we're going to kind of look at how gravity attracts things and how scientists have learned to think of gravity instead of an invisible force, a way to warp the fabric of space-time. What you need for it is, if you have some friends, you just need some stretchy fabric in your friends. If you don't, maybe a hula hoop could work, or because a hula hoop's a little too big for me to work with, I've got this fun little box, and I'm going to stretch a shirt over the box. So something you can stretch some fabric over, and then some different types of balls is what you're going to want. I've got a few fun balls here. I'm going to see if we can't not lose them off the edge as we do this. Pretty simple setup. What you're going to do is you're going to stretch out your fabric. So if it's you and a bunch of friends, you guys are just going to all pull in different directions, and you'll get this nice flat sheet of fabric. If you're on a hula hoop, you can go around the hula hoop and safety pin it in around the hula hoop. And I am just going to put this t-shirt across the top of my box, which is going to be pretty great. It's going to stretch it. It's a little t-shirt. It's kind of a big box, and it's going to stretch it just like that for me. So I have this beautiful stretched out piece of fabric. This is my fabric of space-time. All right, you do want it tight, so I'm gonna hold it down like that, so it's kind of like almost like a bongo right there. Now the first thing we can do is look at what it would be like for a planet in maybe microgravity. This would be like what it's like for most asteroids as they're sort of going through the middle of nowhere. We could throw something in there. So I'm gonna hold that one in my hand. And what you would do is you'll just plop it on. So here's our space-time, and I have this little asteroid that's going around. Now, it kind of doesn't move unless I move it. We can look at the shape. It kind of goes in a line right towards that end where it has that little warped spot. It bumps in, but it sort of travels in a straight line. This is how you would expect something to travel in space when there's microgravity, there's not something really heavy pulling you in. You kind of go in one direction and you just keep going in that direction and nothing makes you curve. Now what we can do is we could add a planet or something for this guy, and we can change the size of the planet by changing either the weight of this ball or changing the size and weight of that ball. It's up to us. And now we can see what happens. And ooh, did you see that? They sort of wanted to go next to each other. Ooh, these guys, they bumped. So we'll go here. And you see how they attract each other on this? Just like gravity. Gravity attracts things, right? We could try with this ball in the middle where it's making, now notice how it kind of pulls it down. That's what our planet does in the solar system. It pulls that fabric of space-time, which is why it's pulling us onto that planet, right? Onto Earth. So this guy sort of comes. Now, if you do this in a big enough hula hoop and you have a nice heavy piece right here, you can actually get things to orbit, which is kind of cool. So we could try here as a nice big heavy planet like the Death Star. And you could see what happens. Now you'll notice now it's no longer a nice straight line that this guy goes in. It starts to curve around it because it's so massive. It's attracting this little marble I have, and it's attracting it because it's curving space-time to go towards it. Now a black hole wouldn't be like me putting something on this. It would be like me pulling the center of this down all the way practically like to the floor so that it would be just super steep. And in that situation, not only can my ball get trapped in it, but even light will get trapped into a black hole, so it can't even escape. It's so massive that it sucks the light in, which gives it the name, the black hole. I'm really excited to see what kind of balls and weights that you guys use in this project as you see how things orbit. If you've got some friends, you can really pull that middle down. You could even have these guys start rotating them and see how two stars orbit each other. It's kind of amazing, all the different ideas that you guys can do with this project. It's a great way to see how gravity works and also how scientists think of space-time as we discover more about black holes, which is kind of amazing. We also, this year, got a picture of a black hole, which is incredible. All right, thank you guys so much for joining me. I can't wait to see you in our Zoom room as we share the different things that we made attract each other or change the way things were moving because of our curved and warped space-time fabric. Have a great afternoon, my friends. Thank you so much for joining us for Nobel Prize winning Science Week. Bye.